Ladies and gentlemen, thank you for attending this conference today. As ag consultants, you are the brains and the knowledge that the farmer needs to take his operations to a new level. That being said, you always need more tools in your toolbox to help the farmer be more efficient. Today, I'd like to show you what irrigation automation can bring to the table to make your job easier and to help the farmer be more efficient and more sustainable in his operations. One of the things that we talk about is sustainability, the ability to use the same soils and natural resources for a long-term ecological situation. Through this, we can use technology to help with that sustainability. For a farm to be sustainable long-term, we have to take care of our environment, take care of our soils, take care of our water sources. We have to have a good labor source or something to take care of that labor. And we also have to be able to operate efficiently so that we can make a profit to continue doing this each and every year. Environmental stewardship is the practice of taking care of our resources, natural resources such as land and water, so that they will be available for use in years to come for future generations. One of the things that electronic automation brings to the table is it gives us the ability to start and stop pumps, to make timely decisions so that water is not wasted and that more water is not pumped than needed to be. This can add up to a 50% savings in water use. Another advantage to irrigation automation is to help reduce labor costs. As we know, labor is hard to come by nowadays, and if we can find labor, it's often more expensive than what we can afford. One of the things with automation, being able to monitor your wells remotely, is that you have fewer visits to the wells. You don't have as much wear and tear on your vehicles, fuel costs, and it gives you the ability to see real time what is going on with your pumps and to see maintenance intervals, whether you need to do anything to the pumps or send fuel out to these pumps. With the ability to see these pumps running real time remotely, you are able to make decisions to either start or stop the pumps when they need to be. And with sensors in the field, you can also trigger these pumps to shut off automatically so that when certain thresholds are met, the pump is shut down automatically so that you don't overwater or run longer than you need to. So talk is cheap. We've been developing this product for over 6 years now, and we have over 150 wells in service in the fields, along with many more telemetry units pulling in moisture sensor data and level sensor data. We started our development with efficient pump control, being able to start and stop the pumps remotely and being able to see their status at any given time so that the farmer knows where to spend his time on each and every day and to make sure that his crops are getting watered the way they're supposed to be. The most basic form of pump control is an electric relay. We can easily start and stop an electric relay and verify that it's running. We also can start and stop a soft start. The VFD control, we can start and stop, control RPMs, run RPMs up and down, and we can also send back RPM feedback so you know how fast your pump is running. Along with the rest of the electrics, we can verify the load shedding to make sure that your load shedding is happening like it's supposed to so that you can get your kickbacks from your electric company for your cheaper electric usage. Also, this gives you the ability to verify how long your pump was pumping, to verify the water usage that you're using. The next step was to take the diesel and natural gas power units and automate them to the point they will start and stop remotely and automatically. We do this by starting them up, letting them warm up. After they've went through a 2 to 3 minute warm-up process, we then engage the clutch control, and once we verify that the clutch is engaged, we will then slowly ramp up the RPM to your pumping speed. Then at that point it will run in that condition until you either stop it from the web page, or if it's set to a timed run, it will run until that time is up. Or we can use a sensor input that once that sensor has reached a certain threshold, it will start its shutdown procedure. In the shutdown procedure, it's going to slow down at around 1,000 RPMs. It's going to disengage the clutch, and it will sit there and idle for 2 to 3 minutes to help cool that engine down. Along with this, we have the ability to do a natural gas valve on diesels, so that if you have natural gas at that pump or propane injection, we can, after the engine is running and under load, we can trigger a valve that will start your natural gas injection, causing your engine to run a lot more efficient, use less diesel fuel, and reduce your costs in that manner. One of the other things about disengaging the PTO before shutdown is that you don't have to worry about the engine running backwards at that time, because the well is trying to drain down. So that is another advantage to this. So after getting the pump control all designed and under control, we knew that there was more information that the farmers needed from their fields. So we've taken it one step farther and added telemetry. And as Admiral Grace Hopper once said, one accurate measurement is worth 1,000 expert opinions. So we're wanting to bring the data to you to help you make a good decision about what's going on in your field. So there are many different things that you can be aware of in your field. One of the things that goes along with the pump station is flow metering, so that you can tell how many gallons you've pumped throughout the season or throughout any one pump session, so that you know how much water your crop is getting. Another thing is we can provide weather stations around your farm so that you can tell weather conditions, how much rain each part of the farm has gotten, wind direction for when you're spraying, stuff like that. We also can monitor water levels in your rice paddies, water levels in your reservoirs, in your canals, any of those things. Soil moisture for your row crops, so that you know when it's time to start the water, so that your crops aren't under more stress than they need to be. We can provide soil moisture temperature. We can even provide an IR temperature sensor for underneath your canopy if you're wanting to monitor canopy temperatures. So there's a few different ways to get your data to the cloud. The one we recommend is cellular. The prices of cellular data just came down tremendously, especially for the small amounts of data that we send from all your sensors and your engine. If you don't have good cellular coverage in your area, we also can do a hybrid network of point-to-point local network to a cellular uplink to get your information to the cloud. But there's easy ways to get all your data to the cloud, even if it needs to be a combination. Like I said, we started developing this system 6+ years ago. Each and every year, we're adding something else to the system. So moving forward, we're always innovating. working on making the system more fluid. So I'll talk a little bit about more what we're doing in the following slides. So now that we have all the components of the system, starting with pump control, telemetry, sensors, all to bring that information back to us, we're going to take all that technology and go to the next step and close the loop. When we talk about closing the loop in electronics, we are talking about taking the sensors in the field and making a decision on that data, and those thresholds are set by the user, and then the system will automatically start and stop according to those levels. It will switch valves according to those levels. If they've been met in one field, then it will switch to a different field, etc., until all the thresholds have been met. Let's start with the simplest scenario. We start the pump based on either a low water level trigger, which will start the pump up and it'll start pumping, or a low moisture sensor level, which then starts the pump up and it starts pumping. Continuing with the simplest scenario, once this pump is pumping, it's going to pump until that same sensor or another one farther down the field, depending on how you have it set up, reaches its top threshold, which is its shut-off threshold, either a water level or a moisture level, and that will trigger the pump to start its shutdown process. So let's be more efficient even than the simplest scenario. We'll take one pump that has multiple risers, multiple valves, and we'll do an automated system that will water more than one field using sensors as thresholds, and then it will shut down automatically. Here in this slide, we're going to show you a little automation diagram that's going to show 4 different fields, and it's going to show the sensors checking in with the pump and requiring water in each field, and the pump is going to switch valves and water each field in succession until each field is fully satisfied, and the pump will then say it's satisfied and shut down. Here in this slide, we're going to show you a little automation diagram that's going to show 4 different fields, and it's going to show the sensors checking in with the pump and requiring water in each field, and the pump is going to switch valves and water each field in succession until each field. Thank you for your time watching this presentation. Well, then we here at Applied Digital Satisfied and shut down. Designers of Aquarius Farm Controls. Here in this slide, we're going to show you a little automation diagram that's going to show 4 different passion for this project, and it's going to show the sensors checking in with the pump years, and support our customers requiring water in each field to have, and the pump is going to switch valves in the coming days, each field in succession questions until please feel free to reach out to us. The next slide will show us will then say it's satisfied and shut down. Check us out at our webpage. We're going to show you a little automation diagram that's going to show 4 different fields. 251. It's going to show the sensors checking in with the pump, or check us out on social media at Facebook requiring water in each field. And the pump is going to switch valves. Farm Controls. Thank you very much. Each field in succession until